A circle and a ray are indicated in the complex plane. The ray has equation argz is equal to the inverse tan of 2. Point C is the centre of the circle. Point P is the intersection of the circle and the ray. Determine the equation for the circle. So we can see the centre here is at 0, 1, or in the complex plane, that's of course I. So we can say that the distance of Z from I is equal to 1 because the radius is 1. Point P determines a complex number. W is equal to R cis theta. Determine the exact values for R and theta. Well, we're already told in the question that the argument of Z is equal to inverse tan of 2. So theta is the inverse tan of 2. And so now we need to look at working out the length OP. Well, since we know that in general a gradient is equal to tan theta, where theta is the angle with the positive x-axis, that tells us that the gradient of our line is 2. So in other words, this line is y equals 2x. So we have y equals 2x, and we have the circle, which is given here, but if we do it in Cartesian form, it's going to be x squared plus y minus 1 squared is equal to 1. So that gives me x squared, let's call that 1 and 2, x squared plus 2x take away 1 squared equals 1. So x squared plus 4x squared plus minus 4x plus 1 equals 1. So 5x squared minus 4x equals 1. So, equals 0. So we've got 5x minus 4 equals 0. So x equals 0, that's the origin, so we don't want that one. Or x equals 4/5. And since the line is y equals 2x, that means that y equals 8/5. So in other words, P is the point, 4/5, 8/5. So R is going to be the square root of 4/5 squared plus 8/5 squared, which is 1/5 of the square root of 16 add 64, which is 1/5 of root 80. Now 80 is equal to 16 times 5, so that is going to be 4 root 5 over 5.